So today's problem is based on tiny research. So the problem goes like this: we are given n months, starting from month one, 2, 3, 4, so on till n, and in each month there are some days. So suppose there is A1 days, there are A2 days, A3 days. So D they are representing by D. So D1, D2, D3, D4, and this is a cyclic array question. So we'll just make a cyclic because they want. So each day is represented like this in a month for this sample we are drawing. So this is the case. So the author wants us to select any continuous date. So you can see this like this. So we have to choose x length path which is continuous, and we want to find the maximum value of that path. So in this x is equal to 2, so the answer is 5. In this, the user can choose from this to this. I think this. So x was 6. So the answer is 12, which is maximum. We want to maximize the continuous path which we choose when we arrange this in a straight line. So and the user can choose anywhere. It doesn't matter from where he starts. So they are given that x is less than this, which means that x cannot exceed 2n size. So this is the case. Now the question arises: what should we use and how should we proceed? So the main problem with this is that we don't know the starting point of from where we should start and if we choose the starting point, then ending point is fixed because if we choose from a 2, then we will use all the x's, because if we use x minus 1, then it will be not good. It will be not really good. So we'll choose the entire path. Because x equal to 3a, then we can use all this. If we start from this x equal to 4, then we can just extend this. If we have the starting point, then we can definitely get the answer. But starting point can be 10 to the power 5 times 10 to the power 6. So they are also very large. So what can we do is we can just see zoom in one array and let's see what is happening exactly. Suppose the array looks like this. Okay. So I'll just make an array. So if I choose starting this and the answer is suppose A1. So and if I choose this as an answer and the answer is A2, then, then this is better, right? So the point which I want to prove here is that this is a monotonic function, which is a parabolic function, and this gives like answer this from day one to day two, day three, day four, maybe minimum, maximum. Sorry, this is concave upwards, so I have drawn wrong graph. This will be like this. So for I don't know, but I don't know the concavity exactly, but this will look like something like this because if 2 gives answer here and 3 gives answer here, then the most optimal answer lies in between them. We are sure about that. So they cannot be answered. Suppose 3 is given some answer. Uh, 3 is giving some answer which is greater than 2. Then of course there is no answer which is between this. So we can just move our lower pointer to 2 and keep our higher pointing where it was initially. And so another feeling which I would like to give you is that suppose we are here and we are here, and the answer for 4 is maximum. So why would I choose to start from earlier? If 4 was giving better results, then moving to 5 might give me more good results, but certainly not moving to 1, because 1 will decrease the probability of getting a good number. Because if this was contributing, so I got this idea because if 2 was contributing because of we take 1 less from the leftmost extreme position. So if I choose that element itself, then I am just fixing 1 instead of a 2, fixing 1 instead of an x. So because last number is x denoting x, so that is not good. So binary search comes into play in this problem. So after choosing the binary search, trinary search which we are doing here, so this is very easy trinary search. A1 is the left part, A2 is the right part. If and I choose the best of two. If A1 is greater than A2, then we move right pointer, else we move left pointer. Answer is equal to 2. And this get function is a little bit tricky to solve. There is no tricky point, but it is little messy to implement. So if we start from this, then these are fixed. So I will draw an array like this. So if we start from this point, then these are fixed, and we'll brute force and check how many of them are valid, completely valid, and then leftover can be assigned manually. Suppose this is the leftover, and then we can assign this is the endpoint, and this is the complete index till where it is complete. So we'll start from incomplete array, and in between we'll get completed arrays, and then at the end we'll have normal array which is the ending point of that array, which I denote by x. So that's it. This problem ends here. Code is very easy, but a little tricky to implement. We have two prefixes: one prefix for count and another prefix for values actual, because the values which we get is d. So 3 plus 4 plus 5 plus 1 plus 2 plus 1 plus 1 as like that. So that we are getting from these prefixes. So that's all.